This is the optional review for our Unit 3 or Unit 4 quiz/test, so bigger than a quiz, smaller than a test. Again, this review, it was the two-sided review. We're not collecting or giving points to, but if you wanted extra practice, extra help, this was the review that you could do in addition to the in-class review. The in-class review is the one that's going to be for points. So we start off here with number 1. It's asking us to find 1 through 8. It's asking us to find the value of x in each parallelogram. So you guys should have your reference sheet as you are going through this. We look at the reference sheet. We know that the diagonals of a parallelogram bisect each other. So these two pieces are congruent and these two pieces are congruent. Okay. So since these, right, this diagonal bisects this diagonal, it splits it in half into 2 even pieces. So we know x and 15 are going to be the same. So x is going to simply equal 15. Number 28, again, it's a parallelogram because it's telling us in the directions it's a parallelogram. So we know in a parallelogram, the diagonals bisect each other. So here's one diagonal, here's another diagonal. They go from one vertices to the other, to the opposite vertices. Okay, so x minus 4 is going to equal 28. We add 4 to both sides. X is going to be 32. You can always substitute back in to make sure we're right. So 32 minus 4 is going to be 28. We know we are correct there. Let's drag over 3 and 4. Same idea here for 3 and 4. Diagonals bisect each other, so 2x minus 4 is going to equal 10. Add 4 to both sides and then divide by 2. And we get x equals 7. Substitute it back in. 2 times 7 is 14. 14 minus 4 is 10. So we know we have the right answer. Okay, number 4. Diagonals bisect each other, so here's our congruent pieces. I'm not sure if this is minus plus. We'll just put minus 4x minus 10 equals 3x minus 2. If it's plus 2, it's plus 2. I don't know why that is blank. Subtract 3 from x from both sides. We get x minus 10 equals negative 2. Add 10 to both sides. X is going to be 8. 8 times 4 is 32. 32 minus 10 is 22. 3 times 8 is 24. 24 minus 2 is going to give us 22. Looks like 5, 6, and 7 are going to be very similar. Pretty much the same. Okay, 5 is a little different. So again, we know it's telling us AC is 24, so the whole thing is 24. We know our diagonals are AC and BD, so we know AC bisects BD, and BD bisects AC. So we know these segments are congruent, and then these segments are congruent. So if this is x, this one is, since it's congruent, is also going to be x. Up here, it's telling us AC, which is this whole piece, is 24. So we know this piece, which is x, plus this piece, which is x, is going to equal the whole thing, which is 24. So x plus x equals 24. 2x equals 24. Divided by 2x is going to be 12. This piece is 12 and this piece is 12. The whole thing is 24. Okay, 6. Again, diagonals bisect each other. 6x minus 22 equals 4x minus 4. Subtract 4x. 2x minus 22 equals negative 4. Add 22 to both sides. 2x is going to equal 18. Divide both sides by 2, x is going to equal 9. 7 and 8. It's telling us in number 7 that EG is x. So EG is x. Again, it tells us the parallelograms at the top. So we know diagonals bisect each other. So these two are congruent and these two are congruent. So if this one's 4, this one is also going to be 4. The whole thing EG is x. So if we add the two parts together, 4 plus 4, we're going to get the whole piece, which is x. So 4 plus 4 is 8. So x equals 8. So EG equals 8. Again, parallelogram, diagonals bisect each other. Okay, it's telling us JK is 35. JK is 35. Or IK. Hard to see this close. It looks like IK on your screen. So IK. So again, if this is 4x plus 3, this was also 4x plus 3. The whole thing is 35. This whole thing is 35. So 4x plus 3 plus 4x plus 3 equals 35. Combine like terms, we get 8x plus 6 is 35. Subtract 6, 8x, it's going to be 29. There goes the cap. It's going to be gone for 2 hours. No, I don't think both these reviews are going to take 2 hours, but maybe. So 8x plus 6, yeah, so we did it right. We're going to just end up getting a fraction. There's nothing wrong with fractions. X is going to be 29 over 8. Okay. All right, we'll go down the page first, and then we will. Okay, here we have parallelograms. Okay, parallelograms. So this time we're going to talk about the angles of parallelograms. But what happened to 10, 11, 12, and 13? Why is 10, 11, 12, and 13 not on there? Oh, it's the wrong side. Never mind. We're good. Okay, we're good. 13. So again, we're dealing with angles here. Parallelograms. So again, consecutive sides of parallelograms are going to be supplementary. We've done this over and over again. Some of you still struggle with this. Opposite sides, the parallelograms, opposite angles are congruent. Consecutive angles are supplementary. So here we have consecutive angles because they're angles that are right next to each other. So these two angles have to add up to 180. The measure of angle 1 plus 80 is going to equal 180. We subtract 80 from 180. The measure of angle 1 is going to be 100. 100 plus 80 equals 180. So it wants us to find the numbered angles for each parallelogram. Here again, we have consecutive angles. We know consecutive angles are supplementary. So 180 minus 140 is going to give us 20. Okay. And then we also know that opposite angles are congruent. So if angle 1 is 20, angle 3 is also going to be 20 because they're opposite angles. And in a parallelogram, opposite angles are congruent. We also know angle 2 is across from the 140-degree angle. Since opposite angles are congruent, angle 2 is going to also have a measure of 140 degrees. Number 15. So again, consecutive angles. So 180 minus 110 is going to give us 70 because they're next to. Okay, we can do opposite angles are congruent, or we can do consecutive angles. So 180 minus 110 again is 70. Okay, we can do consecutive here, 180 minus 70. Consecutive with these two angles, 180 minus 70, or we can do opposite angles are congruent. Either way, we're going to end up with 110. Okay, we'll do 16 and 20 afterwards, so I don't have to move it. Okay, number 17. Easiest one to figure out is angle 1. Angle 1 is going to be 115 degrees because they're opposite angles. But let's start out by finding this whole angle right here. So that whole angle right there is consecutive with 115. So we know consecutive angles add up to 180. So if this angle is 115, 180 subtract 115 from 180, we're going to get 65. So this whole thing is 65. The whole thing here is 65. Okay, it tells us this angle is 50. So we can do 65 minus 50, which gives us 15. So angle 2, the measure of angle 2 is going to be 15. Because this whole thing is 65 because it's consecutive here. And then 50 and 15 have to add up to 65. Angle 1, these are opposite angles. Opposite angles are congruent, so that's 115. Okay, and then here again, we have alternate, well, not again, but the first time in this one, we have alternate interior angles. So again, we have said, I got to stop saying again, but parallelogram is defined as having two pairs of parallel sides. So alternate interior angles are going to be congruent. So this one, angle 3, is going to be 50 degrees. The measure of angle 3 is 50 degrees. See what we got here. Well, this one, we have vertical angles. So we got to apply some of our old properties, our old knowledge of lines and angles. Here we have a linear pair. Okay, so these two are linear pairs. So 180 minus 75 is going to give us 105. We know that 1 and 3 are going to be the same because they're alternate interior angles. We can find 3 because we know 2 angles in this triangle. So if we have a triangle here, we know 2 of the angles, so we can find the third angle because we know all 3 are going to add up to 180. So the measure of angle 3 plus 75 plus 50 is going to equal 180. The measure of angle 3 is going to equal that 75 and 50 is going to give us 125. Subtract 125 from both sides. The measure of angle 3 is going to be 55. So we know that angle 3 is going to be 55. So we have alternate interior. So this one is also going to be 50. I have to be careful how I write my 55s because that looks like the SS symbol. If you know anything about history, the Nazis had the SS. Anyways, make sure they're 5s and not a 2 S's. They're 5s. 19. Same sort of thing. Vertical angles. So this is going to be 72. We have a linear pair, so 180 minus 72 is going to give us 108. That's information from the old units. Back from unit 2. we can figure out this angle right here, because we have these two angles in the triangle. Okay, so 47 plus 72 plus the measure of whatever that was called x. I'm just going to put an x in there. Plus x equals 180, because the three angles of a triangle add up to 180. This is going to give us 79 plus 40, which is going to be 119. Plus x is 180. Subtract 119. We get x equals 61. If I take away these circles, okay. If we combine these two angles, we know these two angles added together are going to be 40 plus 47, which is going to be 87. We then know, since they're parallelograms, that consecutive angles, I'm going to erase the 108 and the 72. So these whole angles are going to be supplementary because they're consecutive angles, and consecutive angles in a parallelogram are supplementary. So 180 minus 87 is going to give us 93. So we know these two angles have to add up to 93. 93 minus 61 is going to give us 32. 32. So we know angle 4 is going to be 32. And then we can do alternate interior angles to find that angle 1 is going to be 61. So the middle ones, we got vertical. So we know that one's 72. We have a linear pair, so we know that one is 108. From there, we can use these angles, three angles of a triangle, add up to 180 to find the 61 down here. We know these two angles added together is 87. So these two angles added together, because down here is going to have to be supplementary to 87. So 180 minus 87 gives us 93. So we know these two added together have to be 93. So 93 minus 61 gives us 32. And then we have alternate interior to get the measure of angle 1. So I'm going to move it over. We will do 16 and 20. 16 and 20. So opposite angles are congruent. So 1 is going to be 113. Okay, from here we know alternate interior angles. So if this is 22, this is also 22. This is 45, this one is also 45. Because we know in a parallelogram we have two pairs of parallel sides. So we know that since the lines are parallel, the alternate interior angles are going to be congruent, because the alternate interior angle theorem says if the lines are parallel, alternate interior angles are congruent. Number 20. So we have a linear pair. So 180 minus 82 is going to give us 98. So angle 2 is going to be 98. Here we have, again, alternate interior angles. Again. We know alternate interior angles are congruent, so this is going to be 50. And that's going to allow us to find the measure of angle 1. Okay, the measure of angle 1 plus 50 plus 98 is going to equal 180, because the three angles of a triangle, the three interior angles of a triangle add up to 180 by the triangle sum theorem. 50 and 98 gives us 148. We subtract 148. We get the measure of angle 1 is going to equal 32. So, well, we gotta go up. So I took some off, but here we have these in the middle. So again, this is the okay. I feel I should have to do like 10 push-ups every time I say the word again. Find the values of x and y for which the figure must be a parallelogram. So in order to be a parallelogram, we know opposite sides have to be congruent. So we know MA is going to be congruent to IP, so we can set those equal to each other. 4x plus 20 equals x plus 26. Subtract x from both sides, we get 3x plus 20 is 26. Subtract 20 from both sides, we get 3x equals 6. Divide by 3, x is going to equal 2. We also know MI is going to be congruent to AP because the opposite sides of a parallelogram are congruent. So 7y is going to equal 6x plus 9. Well, we already know what x is. X is 2. So 6 times 2 plus 9. That's 12 plus 9. 21 divided by 7. Y is going to be equal to 3. We can substitute back in just to make sure we got it right. 7 times 3 is 21. 6 times 2 is 12. 12 plus 9 is 21. 4 times 2 is 8. 8 plus 20 is 28. And 2 plus 26 is 28. Number 8. Again, we have a parallelogram. It's 10 push-ups. We know in a parallelogram that the diagonals bisect each other, meaning this piece and this piece are congruent, and these two pieces are congruent. So our two equations here are going to be x equals 2y and 2x plus 14 equals 5x minus 4. We subtract 2x from both sides. 14 is going to equal 3x minus 4. Add 4 to both sides. 18 is going to equal 3x. Divide by 3, we get 6 equals x. We can then substitute that into our other equation. So 6 equals 2y. Divide by 2. 3 equals y. So x is 6, 3 is y. We can double check by substituting that in. 2 times 6 plus 14. So 2 times 6 is 12. 12 plus 14 is 26. So this one had better be 26. 5 times 6 is 30. 30 minus 4 is 26. 2 times y, so 2 times 3 is 6. And then we know x is 6. So we know we have the correct answers. Number 9. Number 9. So we know opposite angles are congruent in a parallelogram. So we know 2x is going to equal 12y plus 8. But there we have, again, 10 more push-ups. We have 2 variables. We'll keep a running tab there. How many push-ups I'm going to have to do at the end of the day? 2x is going to equal 12y plus 8. And then we have consecutive angles are supplementary. So 12y plus 8 plus 5y plus 2 is going to equal 180. because consecutive angles in a parallelogram are supplementary. First angle and second angle are supplementary, so they add up to 180. Combine like terms, we're going to get 17y plus 10 equals 180. Subtract 10. 17y is going to equal 170. Divide by 17, we get y equals 10. We can then substitute that in for y. So 2x is going to equal 12 times 10 plus 8, which is 120 plus 8, which is 128, which is going to be x equals 64 once we divide by 2. We can substitute that back in to make sure. So 2 times 64 is 128. So this one had better be 128. 12 times 10, right, y is 10. So 12 times 10 is 120. 120 plus 8 is 128. And 5 times 10 is 50. 50 plus 2 is 52. 52 plus 128 is 180. 52 plus 128 is 180. So everything checks out. These again are parallelograms. That one works, so that one doesn't count. That one works. Now we can 30. Not all at once. Well, I can do 30 at once, but not. It's going to be way more than I can do at once. Algebra. Find the value of x, then tell whether the figure must be a parallelogram. Explain your answer. So, in order for, well, it gives us two congruent sides. So 3x minus 2 equals 2x plus 6. Because if it's a parallelogram, opposite sides are congruent. Subtract 2x. We get x minus 2 equals 6. Add 2 to both sides. X equals 8. So we have to plug it into or substitute it into these two, see if they're congruent. So 8 plus 4 is going to be 12. 2 times 8 is 16. 16 minus 4 is 12. And just to make sure we did it right, 3 times 8 is 24. 24 minus 2 is 22. 2 times 8 is 16. 16 plus 6 is 16 plus 6 is 22. So x is 8, and it is a parallelogram. Number 11, we know that consecutive sides are supplementary and opposite sides are congruent. So we can do x plus 30 equals 2x. Subtract x from both sides, 30 equals x. Make sure it works for everything. 2 times 30 is 60. 30 plus 30 is 60. So these two angles are going to then have to be 120 and 120 because we know consecutive angles are supplementary. So let's see if it works. 3 times 30 is 90. 90 minus 15 is 75. So right away we have issues. 2 times 30 is 60. 60 plus 25 is going to be 85. So these aren't even equal. So this is not going to be a parallelogram. We would need all consecutive angles to be supplementary and all opposite angles to be congruent. So this one is going to not be a parallelogram, not a parallelogram. This one is a parallelogram. Number 12. So in a parallelogram, we know consecutive angles are going to be supplementary. We also know that alternate interior angles are going to be congruent. So here we have alternate interior angles. So 50 is going to equal 2x. Divide by 2, 25 equals x. So we substitute that in. We can see if it's going to work. 25 times 2 is 50. 4 times 25 is 100. 100 minus 10 is 90. And then 25 plus 15 is 40. So this angle is 40. This angle right here has to be supplementary. So that one's going to have to be 140. 180 minus 40 is 140. 90 plus 50 is 140. So it looks like that one's going to work. This one is going to be a parallelogram. The numbers are going to work out for us. So number 12 is a parallelogram. Name all the properties that are unique to each of the following quadrilaterals. Which properties do each of the quadrilaterals have that the others do not have? So we go through, we know there's 5 properties on our reference sheet for parallelograms. Let's see if each of them are unique. Hope I don't screw up because I don't have a reference sheet in front of me. But let's see. So parallelograms have 2 pairs of opposite sides. So 2 pairs of opposite sides that are parallel. So rectangles, rhombuses, and squares are parallelograms. Our other 3 that we have are trapezoids, isosceles trapezoids, and kites. Trapezoids, including the isosceles trapezoids, have 1 pair of parallel sides. Kites have no pairs of parallel sides. So yes, this one is going to be a unique property of the parallelogram. Next one, 2 pairs of opposite sides. What do we say? Sides are congruent. So we know that's true for rectangles, rhombuses, and squares because they're parallelograms. So we have to look at our other categories here. Trapezoids. Are they going to have 2 pairs of opposite sides that are congruent? No. If they had 2 pairs of opposite sides that were congruent, they would not be a trapezoid. They'd be a rectangle. Or rhombus. So we know that's not going to be true. So we know that this is a unique property. I'm going slow so I'm thinking of every option so I don't screw up these answers here. Next we have 2 pairs opposite angles congruent. That's also going to be a unique property of a parallelogram. There's also a unique property of parallelogram. So trapezoids do not have 2 pairs of opposite angles that are congruent. Kites have 1 pair of opposite angles that are congruent. Then we have consecutive angles are supplementary. So in a isosceles trapezoid, We know that we have the consecutive angles between the bases are supplementary. But in the parallelogram, all consecutive angles, no matter which ones we pick, so here and here, supplementary, 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 supplementary. So this is a unique property of parallelograms. And the last one is that the diagonals bisect each other. Okay, and that one is also going to be true. In a kite, we have one diagonal is bisected. The main diagonal gets bisected. But this one's saying diagonals bisect each other. So all five of our unique properties for parallelograms are unique properties that show that the quadrilateral is a parallelogram. For isosceles trapezoid, see if we can remember all of the properties that we have here. So we know that the consecutive angles between the bases, consecutive angles between bases are supplementary. So the consecutive angles between the bases are supplementary. So that's not really going to be a unique property because we know parallelograms have two or all their consecutive angles are supplementary. So this one we're going to say is not going to be a unique property unless we know for sure that the other one is not consecutive. We also have that diagonals are, well, we have base angles are congruent. So, again, not totally true for an isosceles trapezoid because we know squares have base angles that are going to be congruent, though we don't really call them base angles, so I'm not really sure what the interpretation is here. So the consecutive angles of base angles, right, these were parallel sides and these were parallel sides. So we're going to put a no on that one as well. We also know diagonals are congruent. But we know in a rectangle, we know the diagonals are congruent as well. So we know that one's not a unique property. And then the last property we have for isosceles trapezoids here are going to be that we have exactly one pair of parallel sides. That's unique of trapezoids. Okay, and then we know that the legs are congruent. Okay, and that's again not really unique because in a square or a rhombus or a rectangle or any parallelogram, opposite sides are congruent. So having legs that are congruent isn't really going to be a unique property. And depending on how you look at it, this isn't a very good question. I inserted this question with better intentions. It turns out it's not a very good question. Kites. So if we look at kites, we're going to have two pairs of consecutive angles that are congruent. So two pairs consecutive. Again, we know in a rhombus, all the sides are the same, so we're definitely going to have two pairs of consecutive sides that are congruent. So this one's not going to be unique. This one has one pair of opposite angles are congruent. And again, it's debatable on the semantics really here. If you were to say exactly one pair of opposite angles are congruent, then we could say, sure, that's a unique property. But if it's just having at least one instead of exactly one, then we would say no. But if you want to say exactly one pair and only one pair, no more than one pairs, then it would be a unique property. Diagonals are perpendicular, so diagonals are perpendicular. This one's definitely a no, because we know in rhombuses, the diagonals are perpendicular. We also know one diagonal is bisected. Again, in a rhombus, we have in all parallelograms, the diagonals are bisected. So again, depending on how you look at it, if you're saying only one diagonal gets bisected, then sure, it's a unique property. But we know in parallelograms, there's both diagonals are going to be bisected. They bisect each other. And our last property here is that we have one pair of opposite angles are bisected. So again, if it's exactly one pair, it would be a unique property. But in rhombuses have all of their angles are bisected by the diagonals. Or one of the properties of a rhombus is opposite angles are bisected. So I'm not sure how useful that question was. The time I wrote it, it was 3 a.m, and I thought it was a great question. Looking at it now, maybe not so great. I don't know. What do I know? Not a lot. What do we have here? Okay, this is the back page now. Should we cut it off and make 2 videos? Part 2, or should we keep going? What do we have? 42. We're definitely going to stop and make part 2. So that's part 1. That's the front half of the review for the optional review that we're having for the big quiz / small test on quadrilaterals. Okay, I will right next to it or right below it. I'm going to have part 2, the second page.